All right, here's 7.1 day 2. All right, still really focusing on angles. Doing a couple different things with angle measurements in both radians and degrees. Day 1, we really focused on converting from one angle measurement to the other. We're not going to do so much of that today as much as we're going to talk about the topic of a coterminal. Now, I want to come back to the definition of a radian to just be clear on that. What a radian is all about, and it's just an alternate method, I shouldn't say method, an alternate unit of measure to measure angles. Okay? It is defined that if we have an angle in a circle, in particular a central angle, it is defined to be the intercepted arc length over the radius of that circle. So again, we could divide that as arc over radius. For example, if I choose a point on that circle, okay, that determines an angle. Okay, I think if I just like I drew in those two sides, the measurement of this angle is determined by where I picked that point. Now here, the radius of this circle is 7, but another thing that where I picked that point determined is how long that arc was. Let's say, for example, it's 15. Okay? That arc relative to the radius is the definition of the unit of radians. So I drew in the numbers for this particular case, but if we had an angle that when we drew it on that circle, that it led to an arc length of 15 with a circle that had a radius of 7, that is about 2 1/7 radians, a little over 2 radians. Okay? This is big to remember right here because we don't use radians as often. Well, we will. But as far as what you've previously done, you probably haven't done all that much with radians as compared to degrees. So it's important to be very clear on what their definition is and what a radian is. Arc length over radius. Next piece is called a coterminal angle. I want to define a couple pieces in terms of vocabulary. This side right here is called the initial side of an angle. It never moves. Okay, anytime we talk about an angle on a coordinate plane or kind of an angle inside a circle, that's always the initial side. Okay? This other side is what we're referring to above when we say the terminal side. Now that can move, and that depends on where I pick that point on the circle, which then determines the angle. The definition of a coterminal angle, or coterminal angles, are two that have the same terminal side. Okay, that basically means they are in the same position on the circle. Now, if I were to just look at approximating this angle, I would say it's probably right around 110 degrees. It's a little bit bigger than 90 and well short of 180. That's how I estimated it at 110. Now, if I want to get a coterminal angle, it's pretty straightforward. I would take 110 degrees, and I could either add or subtract 360 degrees. Okay? If I were to do both here, this would lead to two other angles that are also coterminals. One of which would be 470 degrees. If I were to subtract 110 minus 360, that would be negative 250 degrees. Okay? All three of these angles are what we would call coterminals, because even though they're different measurements, they would all have the same terminal side, and they would be in the same position if we drew them on a coordinate grid. Okay? Now, how we account for an angle that's bigger than 360 and one that's negative, we'll get to that in a bit. So here's what we're doing in these examples. There's not a whole lot to these. anytime you want to generate coterminals, take the angle that you have, add 360 to get one, subtract 360 to get another. Okay, we'd want those written as a single number to have a final answer. Okay, now it says to generate one that's positive and one that's negative. So notice here with 500, if I were to subtract 360, that would equal 140 degrees. There's a positive one. In this case, I wouldn't want to add 360 to 500. I could. I generate another coterminal at 860 degrees. Problem is, it would be another positive one. I can take 140, and I can go ahead and I could subtract 360 again, and I could get negative 220 if I want to make sure I get one positive and one negative. Okay, so if it asks for that, a positive one and a negative one, don't just add 360 once and subtract 360 once. You may have to subtract twice. It depends on the angle that you're starting with. On number 10, don't forget that we are not at all interested in doing this when we're in minutes or seconds. Make sure you convert that. Okay, that's 100 degrees in 14 minutes. We'd want 100.23 degrees, and then we could add or subtract 360. Okay, it's kind of like we said yesterday with the degrees, minutes, and seconds thing. If we're doing any type of calculations, it's really easier to just be in a decimal form. So if you see that, make sure you recognize it and convert it to decimal form first thing. Instructions here are the same, but these angles look much different. Okay, it's because they're in radians. And again, it's not necessarily because we see a pi in the angle measurement. It's because there's no degree symbol. Okay, it's not marked degrees. Again, that is the very consistent thing to go off of if it's radians or degrees. Okay, so the concept of a coterminal is the same in the sense that it's really about 360 degrees and adding or subtracting it. However, with radians, we need to work with 2 pi. So there's a little bit more going on here. If I had pi over 6, okay, I'm gonna add 2 pi. We're dealing with fractions, which is not a huge deal. It does mean for 2 pi right here, I would need to write that as 12 pi over 6. I'm getting a common denominator. I add those together and I get 13 pi over 6. I could also subtract to get a negative 1. I can use the same form of 2 pi, which is 12 pi over 6. When I subtract those, I get a negative 11 pi over 6, and there's your negative 1. I should double check to make sure those can't be simplified. 13 over 6, that looks good. Those don't have any common factors. 11 and 6, same thing. Okay, those can't be reduced. So it really is the same concept because, you know, all we did with radians is we changed units. Okay, a coterminal angle, if they're in radians, is still 2 angles that share the same terminal side. We're just measuring them in a different way. So all it really means here is be sure to add or subtract 2 pi and not 360. Now let's take a look at how we write angles on a coordinate plane. Well, right here we have our initial side. The first one I want to look at is 200 degrees. 200 degrees here would be right about there. My angle's positive. I always open up counterclockwise. And so I would mark that on there that I've opened up counterclockwise. Notice I've gone a little bit past 180. So I'm just kind of estimating as I'm sketching it on here. Okay. I've gone a little bit past. To make these a little bit easier to look at, I'm gonna blow them up here a bit. Okay, so that's what 200 degrees would look like. Now, let's think, what if we had a coterminal, okay, and a coterminal for 200 degrees. Disregard that dot, I'm not even sure how that showed up. Would be 560. Okay, now it's the same position, okay, so how do we mark on here that it would be 560? Well, I'll mark this one in red, okay? It goes to the same position, but then we keep going again, which is like adding 360. So that's how I would mark in red that's a 560 degree angle. So what's different if it's negative? We still start at our initial side. I just open up the opposite way. Okay, remember with this positive angle on number 1, I opened up counterclockwise. Here, I'm going to open up clockwise. Okay? There's negative 125 degrees. Same type of thing if I added or subtracted 360. I could get coterminals and I'd mark them the same way I did in the first one. Okay, but negative just opens, maybe that's something you want to write in here. A positive one opens counterclockwise. And, excuse me, I'm not sure if I said that right. The positive one opens counterclockwise. The negative angle opens up clockwise. Now that makes more sense when we get to the unit circle. Right now, I think intuitively it kind of seems backwards. That you think, okay, a positive angle opens up counterclockwise and a negative angle opens up clockwise. Yes, that's the way it is. Probably seems strange. Hold that thought until we get to the unit circle and we get to marking like first, second, third, and fourth quadrants. And then you'll see it and likely see that, oh, it does actually make way more sense that positive angles open counterclockwise. For in radians, same deal. Okay, I can see this is a positive angle, so I'm going to open up counterclockwise from the initial side right here. Okay. Now I just have to use different reference points. 90, 180, 270, that type of thing. Obviously I'm talking in degrees. Those are the best to go off of. Remember over here at 180, that's pi. And I can tell from here that because pi is 6 pi over 6, this is a little bit less. We don't quite get to pi. And so I would mark right there. That's 5 pi over 6. Okay, I opened up counterclockwise, and it's marked, because I put in that little arc, going counterclockwise up to the terminal side, which is just a little bit short of pi. Okay, so that's how we mark them. As always, if you had any questions on those examples, make note of those. And next time we see each other, please bring that question to my attention.